So let's jump into our next topic, which is collections and lists. Now, we talked about four types of data, four variable types that we can have, right? We have a string, we have an integer, which is a number with no decimals. We have a float, which is a number with decimals, right? And we have Boolean, which is, it can only be true or false. And we've talked about um, maybe in the future I would add some things. So this is welcome to the future, guys. We're going to add another type of variable. And this one's a little bit weird because it's a variable that can hold multiple things. It's called a collection. And there are a number of different types of collections that we use in Python. We're going to really focus on two. And I'm going to introduce you to one today, which is the most common type and the most frequently used. It's called a list. And in a list, we can have multiple pieces of data in a single variable. So a list, what's a good way to think about it? Does anybody know what a bento box is? Seen a bento box? If you go to your favorite, what's that? Yeah, it's for food. It's like a Japanese lunchbox, if you will, right? If you go to your favorite sushi place, a lot of times they have a bento box on the lunch menu. And typically, what a bento box looks like is it's a little box. And if you look online for bento box images, you can see some people put a lot of care and craftsmanship, and they cut the food into like little animal shapes or Pokemon or whatever. They're fun. But the other thing about bento boxes is that they have lots of little compartments. And each compartment can have different kinds of food in it. And it kind of keeps the food separate, and each little compartment does its own thing. That's a great way to think about a basic collection, because in a collection or a list, you've got a variable, a container, and inside that container has lots of little compartments. How many compartments can a list have? Almost infinite. Almost infinite. And it can each compartment can contain a different kind of data. So an example of what a list looks like in code, and another name for a list is an array. List and array are the same thing. So if you've studied other languages, you've probably heard those called arrays. And sometimes I'll slip and say array when I mean list, or list when I mean array. Just know that those are exactly the same thing, no different in Python. But Python calls them lists. Sometimes I even define my variables with AR for array instead of LI for list. It's just an old habit because literally every other language calls them arrays. But a list takes a variable, and we use assignment, which is the equals. So we say AR pets equals, and then notice how this is structured. This is a list of strings. It has 4 strings in this list. Okay, we've got dog, cat, fish, and bird. And I know it's a list as opposed to another type of collection because it's surrounded by square brackets. So we have square brackets, and each item in that list is separated by commas. I can put anything there. This could say dog, 23, true, Bill. It doesn't have to be all the same type of data. It doesn't have to be even related to each other. Most of the time they are a collection of things that are related to each other, like these are like a list of pets. If I wanted to use this list of pets in my program, now I have it. Okay? Now, once I define a list like this, it will stay in the same order. So the first thing in this list is always going to be dog. The second thing is always going to be cat. They're going to stay in that order until I destroy the variable, until my program stops running, or until I do something to change that. which I can do. It just isn't going to change by itself. So the handy thing about lists is that you can always count on them to stay in that same order until you change it. And that's useful to us because it allows us to do things with that list that are important. So that's what we mean by ordered, right? They're in an order and the order matters. They are also indexed. And what that means, indexed, is that each one of these has a number associated with it. Because I might not know what's in each one of these slots, but I can find out by calling that slot's index number. Pretty easy to remember, but there's one trick to this. If you were going to give these numbers to keep track of those slots, what number would you give the first one? A lot of people say 1, and somebody already knows the secret, right? You give it 0. 0, 1, 2, 3. Every time you hear the word index in any programming language, it should be a trigger for you to remember that index starts with 0. Indexes always start with 0. You'll deal with indexes throughout your whole programming career. So whenever you think of an index, and an index is just a series of numbers that points to something. In this case, these numbers point to these slots in this list. So indexes always start with 0. So dog is going to be in the 0 slot of this list until I change it. Cat will be in slot 1, and so on. Now, the nice thing about a list is that in addition to being ordered and indexed, they are also mutable. And mutable is just another way of saying you can change it. There are collection types that are immutable, which means you cannot change them. But a list is changeable. I can put horse where I have cat if I want to. I can change these to be in alphabetical order if I want to. They'll stay that way until I change them again, but I can change anything I want about any part of this list because it's mutable. Okay, and here's the real power of lists. They can have any object or data type, including lists. So I could take dog, for example, and replace it with a list of names or a list of numbers. So you can have lists inside of lists, inside of lists, inside of lists. And when we do that, we put lists inside of a list. It's called a data structure. Okay, and it looks a bit like a tree or some kind of a structure if you see it visually. We're not going to do that yet, but it is coming. We will deal with data structures in this class, for sure.